So I already have a video for solving quadratics, and it goes through a brief overview of all the methods that we have, but I wanted to do to focus on solving quadratics by factoring, especially because we will be using this throughout the rest of the term. So it's a really important skill to know how to do this. So first, we're focusing on quadratic equations. So what is a quadratic equation? And a quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0. So last week we were talking about quadratics and factoring. And so it's basically where you have a quadratic equal to 0. And what makes it quadratic is that the highest exponent is 2. So that is also called the degree of the polynomial. So we also call this a second degree polynomial equation. And the degree of the polynomial tells you how many solutions you have. So because it's second degree, we have a maximum of 2 solutions. I say a maximum because it's possible to have no solution. It's possible to have one solution if you get the same number twice, and then you can have 2 solutions. So that's why we say there's a maximum of 2 solutions. Compare this to a linear equation where the exponent is 1, so there's one solution, but it's also possible to have no solution. So that would have a maximum of 1 solution. So the highest exponent tells you how many solutions it's possible to have, like the highest amount that you could have for that equation. So to solve by factoring, we use what is called the zero product property. And this is also called the zero factor property. So you'll see it, our textbook uses zero product property. I usually call it the zero factor property. You can find either one if you look for this online. I've seen both terms used. Basically, what the zero product property says is that if you have factors, which are just things, multiplied together and they equal 0, then at least one of those must be equal to 0 itself. So for example, or the actual definition we have here is m times n equals 0, then m equals 0 or n equals 0. Basically, if you have things multiplied together and they multiply to 0, the only way to have 2 numbers multiply to 0 is if one of them is 0. But that's just the rule of multiplication, that anything times 0 is 0. So if you have 2 unknowns and they multiply to 0, one of those has to be 0 in order for the rule of multiplication to hold, for those to multiply to 0. But we don't know which one is 0. It could be m, it could be n, it could be the first one or the second one. And so that gives us 2 equations, basically. So you have like m times n equal to 0. And to get we get 2 possible solutions by taking those 2 things and saying at least one of them is 0. If I solve for that, what do I get for the variable? And it is possible that both of them equal to 0, because 0 times 0 equals 0. So that's what the zero product property is basically saying, is that if you have things multiplied together and they multiply to 0, then at least one of those factors, one of those things has to be 0. And so this is the idea that we use when we're solving quadratic equations by factoring. So I've got the steps here in this next slide. And in order to start out, you have to put your quadratic in standard form, which is where everything is on one side and it's equal to 0. This is different from where we solve linear equations, because when you solve linear equations, you want the number on the opposite side. But in this case, we want the number on the same side. So the process is different for a quadratic versus a linear. So you're going to want to make sure that when you see equations, you can identify, is this quadratic, is this linear, because there's 2 different processes depending on which one it is. So for a quadratic, everything needs to be on the same side so that you have 0 on the other side. And then not everything can factor, as you learned last week when we were doing factoring. So in order to solve by factoring, it has to be something that can be factored. So you can always check to see if it can be factored by determining the discriminant. And the discriminant is b squared minus 4ac. So you plug in your numbers for a, b, and c based off of the standard form. So they are basically the coefficients and then the constant term. So you identify what those numbers are, and then you plug them into this equation. That's called the discriminant, b squared minus 4ac. You follow your order of operations, and if your final number that you get is a perfect square, and a perfect square, let me just make a list of those. These are numbers that we can take square roots of. So 4, 9, 25, 36, 49, let's see, that's 2, 3, 4, 5, wait, 2, 3, oh, I missed 16. Just stick that there. I'm trying to do them in order, totally missed 16. So that's 6, 7, 8, 64, 81, 100, 121. I think the next one is 144. Let's see, that's 12. 13 is 169. That's all the ones that I have memorized. And then I also know 15 is 225, but I don't have 14 squared memorized. But if it's one of those numbers, something that you can take the square root of, that means that your thing can be factored. So I get often the question, when do I factor? Or how do I know that I can factor? And this is the rule to check. You check the discriminant. So you can plug in those numbers from your equation, and then if it comes out to one of these numbers, or you're able to take the square root of it, then you can factor. Usually I don't do this check. I'll just try to factor, and then if it doesn't factor, I move on. That's what I do. But if you're, that's because I've done factoring enough that I'm confident I'm going to not make a mistake. If you are not that great at factoring because you're just learning it, you're going to struggle with the factoring part, and so you don't want to give up if it's just you made a mistake. So I would recommend doing the discriminant until you really get good at factoring, and then you're confident enough that you can tell whether it factors or not. That's my advice. So you've gone through this, you put everything on one side, you checked the discriminant, you can factor it. That is where you actually need to go to the process now. So your first step is always try to factor out the greatest common factor, because that will make the rest of your work easier. Once you've done that, and if there's no greatest common factor, you just skip to the next step. But once you've done that, then you use the zero. Oh, I forgot. I actually, as I'm looking at this, I totally forgot the step where you actually factor. You factor out the GCF, but then you need to actually factor your quadratic. I totally missed. That should be step 2. I can't believe I forgot to write that down. I was making this morning, and I guess I had a little brain fart there. So you need to actually do the factoring after you factor out the greatest common factor. And then once you've factored it, then you use the zero factor property to rewrite the equation. And basically, that's where you're creating 2 separate equations. So the whole point of using the zero factor property is to rewrite 2 separate equations. And then you solve each of those linear equations produced, because what this whole process takes something that has 2 solutions, a quadratic, and by factoring, we're able to split this apart into 2 separate equations that are linear. And linear equations are easy to solve. And you will find as we go throughout this whole class that all these different types of equations you learn about, you always ultimately end up turning them into a linear equation in order to solve. That's sort of what we do, is we try to take these more complicated equations and make them linear, because those are easy. And so that's what we're doing here is we're taking something that has an x squared, we're turning it into two linear equations, and then that way we know how to solve it because we can solve for x. So that's the ultimate goal here. Okay, so from here, I'm going to go through a series of examples, and as usual, they're going to get more complicated as they go. These first ones are already factored. I figure I'll start with ones that are already factored so you get used to the zero product property. And then we'll get more complicated. We'll get to ones where we need to factor, and we'll kind of ramp it up from there. So we're starting with ones that are already factored so we can just focus on using that zero product property. So the first example here on the left, we have 3x times x minus 3 equals 0. So we're going to use the zero product property. And the zero product property says that each thing gets set equal to 0. So basically, you can kind of separate it out where the parenthesis is. And so you have two equations, 3x equals to 0, and then the other one says x minus 3 equal to 0. So the zero product property is just taking each piece and setting it equal to 0. And then step 2 is to solve these equations. So to solve the 3x equals 0, you're solving for x, so we divide both sides by 3. And this gives us x equals, and then 0 divided by 3 is 0. So we get one answer, x equals 0. Then we solve the second equation here. So I'm adding 3 to both sides to solve for x. This gives us x equals 3. And that is our second answer. So when you have something that's already factored, you just set each of those factors equal to 0, which is the zero product property, and then you solve those two equations you created, and those are your solutions. And you can check your work by plugging them into the original equation. And you will see that you'll end up getting 0 times something equals 0, or something times 0 equals 0, but it will work out. So if we were to check these, so if I was to check x equals 0, I would plug in 0 for x into our original equation. 3 times 0 minus 3 equals x. So order of operations, I need to do the subtraction in the parentheses first. 3 times 0 times the 0 minus 3 is negative 3. And then I multiply. 3 times 0 is 0, and 0 times negative 3 is 0. So we get 0 equals 0. So that works out. If I check my other solution, x equals 3, so I plug that in for x. So I have 3 times 3, and then in parentheses 3 minus 3 equal to 0. So I need to do the subtraction in parentheses first. 3 minus 3 is 0, so that gives me a 0 there. 3 times 3 is 9. 9 times 0 is 0, so we have 0 equals 0. So math works out. These multiply to 0. Now, if you were wondering, well, what if it's not equal to 0? If it's equal to 5, can I still use this rule? The answer is no. This rule only works when it's equal to 0. You can't use this rule if it's equal to any other number, because let's say it's equal to 5. You have lots of ways to multiply to 5. You can have 1 times 5, 5 times 1. You don't know which order the numbers are in. If you have a different number, like let's say it was equal to 16, you can do 1 times 16, 2 times 8, 3 times 4. You have the opposite order. There's lots of choices. But when you're multiplying to 0, you only have two choices. One is 0 or the other one is. You're limited. Even with like 5, we had 4 things to check. So you want to make sure this equals to 0 because that gives you 4 possible, or that gives you 2 answers and you know they're going to work. If it's equal to another number and you tried the rule, like if it's equal to 5 and you tried setting equal to 1, 5, and then equal to 5, and then equal to 1, you could come up with extra solutions and it's not going to work. So it has to equal 0 for this rule to apply, for you to be able to use the zero product property and solve. So if it's equal to anything else, the first step, get it equal to 0. So second example here, again, this is already factored. I have 2t minus 5 times t plus 6 equals to 0. So when they're both in parentheses, it's pretty simple. You just split it up, and each gets equal to its own equation, and that's using the zero product property. So we have 2t minus 5 equal to 0, and then t plus 6 equals to 0. And I always make my t's curved so that they don't look like plus signs, because you don't want to misread your handwriting. I noticed on the week 1 quizzes that there were a few problems, or there was, I think one of them, some people got the letter Z and they got it confused with the number 2. So you want to make sure that your handwriting, that you can tell your Z's from your 2's, your T's from your pluses, 1's from 7's or L's. You want to make sure that you're very explicit. You know what letters you're using so that you don't get confused. Because if you misread your own handwriting, then you're going to get the wrong answer. So the zero product property lets us set these equal to 0, and then you solve each of these equations. So if I solve the 2t minus 5 equal to 0, my first step is to add 5 to both sides. So that gives me 2t equals 5. Then I need to divide both sides by 2. And so that gives me t equals 5 over 2. And so that is our first answer. Second equation, I have t plus 6 equals 0. So we want to subtract 6 from both sides to solve that one. And we get t equals negative 6. And so that is your second solution. And I'm not going to go through and check these, but they will work. If you plug these in, if you checked it on your own time, you will find that when you plug them in, your left side equals 0. So you end up with 0 equals 0, which is a proof that this works. Moving on, these are factored, but these are a little different. And so I wanted to cover these because this is sort of an extension. It's the same zero factor property or zero product property, but we can add a little twist to it. So let's look at what we have on the left. On the left, I have t times t minus 6 times 3t minus 11. So this is actually not quadratic, because we have 3 t's multiplied together. Ignore the numbers. So this is actually called a cubic equation. So it's technically not a quadratic because we've got 3 t's multiplied together there. However, we can still use the zero product property or zero product rule because it's factored and it still applies. Because if I have like 9 times 0 equals 0, 9 times 2 times 0, it still works. At least one of them still has to be equal to 0. So we can still use the zero product property even though it's not technically quadratic. So because these first few I'm showing using the zero product property, We introduced that with quadratic equations, but it can be applied for things that are not quadratic as long as it's factored. So to use that, we're going to use our zero product property here. We're going to set each equation or each piece equal to 0. And we've basically got 3 pieces here. So we're going to have 3 equations. You're going to have t equal to 0, which we don't even need to solve. It's right there. We will have t minus 6 equal to 0. And 3t minus 11 equal to 0. So the first piece, t, we don't really need to do anything with, but we do need to solve the other 2 equations. So to solve t minus 6 equal to 0, you just add 6 to both sides. And we get t equals 6. Then we solve 3t minus 11 equals 0, so I'm going to add 11 to both sides. This gives me 3t equals 11. Then I divide both sides by 3. And I get a fraction 11 over 3. So that is our third solution here. So we have 3 t's. It's a cubic, which would mean an exponent of 3. We have 3 solutions. So even though not quadratic, we could still use the zero product property to get a solution. Now on the right, I've kind of changed things up here. For one thing, the 0 is on the left instead of the right. That's completely fine. It's still equal to 0. And then we also have 3 things multiplied together, but one of them is a number. So there are 2 ways that we can basically look at this. You could look at that -4 there and say, okay, let's divide both sides by -4 so that we don't have that third thing multiplied there. So you could divide both sides by -4. 0 divided by -4 is 0, and it basically is irrelevant. It kind of just disappears. The other way that you can look at it is with what I just did on the left for the zero product property. Where you set each thing equal to 0. And you would end up with -4 equals 0, x minus 7.5 equal to 0, and x minus 9.3 equal to 0, which I kind of smushed in there. But -4 equals 0 is meaningless, so you can just ignore that. So even though we have 3 things multiplied together, we still have only 2 solutions because there's only 2 things multiplied that involve x. Because of that -4 not involving a variable, it basically doesn't count, and we don't really need it when we're solving. So when you're using the zero product property, if you have a number in front that you factored out, you can just ignore that when you do the rest of your solving. So we're just going to solve x minus 7.5 equals 0 and x minus 9.3 equals 0. And if you notice any patterns, and I strongly recommend that you try to notice patterns, your answer is basically the opposite of the sign that you see. 7.5. So it's x minus 7.5, so our answer is a positive 7.5. It's basically the opposite. And I'm kind of running out of room here, so I'm going to just rewrite this one easier, nicer. So the other one, you add 9.3 to both sides. And so your answer is 9.3 because it was x minus 9.3. So our answer is a positive 9.3. When I was first learning factoring, solving by factoring, I was first taught this after, this was like one of the first classes that I took after I had my experimental math if you watched my introduction video, I talked about the kind of weird math program that I was in and how I left it not really knowing how to do anything. And so we're learning this. And I didn't understand factoring, or I could kind of factor, but I didn't understand the solving. And so I looked for the patterns, and I noticed, oh, my answer is always the opposite of the sign. And I kind of looked for those patterns so that I could figure out the answer without actually going through the solving process. So like with the 3t minus 11, I kind of noticed, oh, it's always set up this way, so that will give me a positive 11 over 3 as my answer. It worked. I noticed the pattern, you know, and it's entirely correct. It always works out that way. So I was always able to get the answer by the pattern, but I didn't understand what was going on because I was finding a shortcut. I knew the pattern that the answer had to look like, but I didn't understand why it was working. So I missed the whole why behind it because I didn't have the foundation, and I was trying to figure out, well, what is actually going on here? So while it's good to look for patterns and look for shortcuts, you sometimes you miss why we're doing it. And what we're doing here is that zero product property. It just goes back to the idea that these things have to equal to 0, so at least one of them is 0. And so then you just solve these. So if you keep that in mind, if you understand why this is happening, it will help you if you come across different equations that don't look like this, that may have different patterns, because the same rule applies. Later in the class, we'll get to things where you have something like an x squared minus 9.3. My pattern wouldn't work in that case because of the x squared. But as long as you understand the zero product property, that doesn't matter because you know the procedure. So it's really important to know the procedure and know the rule, because even if it looks different, you can still get the right answer, as opposed to trying to find shortcuts like I did and it wouldn't work. So just a little FYI there based off of my own experience, that you may be tempted to find shortcuts, but sometimes if you don't actually understand what's going on, it's not going to serve you well. All right, so we've gone through the examples where things were already factored. Now we're getting quadratics that are not factored. So the first step is to factor these if there's no greatest common factor. And these don't have a greatest common factor. I'm just kind of adding in a layer of, complexity each time. So these have no greatest common factor. So our first step is to factor these. I am not going to be going through the whole factoring by AC process. I'm going to do these by guessing and checking, or trial and error, because these are small enough. But if you, on your own, I'm going to just go through and do the factoring, because the focus on this lesson is on the solving part, not the factoring. We've done videos on factoring, but I recommend that if you're not following my factoring process, that after this session is done, you try to fill in those blanks on your own. Take the time to do the factoring on your own, so that way you can fill in those blanks and fill it in your notes as needed. Or if you need additional help with the factoring, go back and review the factoring videos, because I don't want to spend all my time factoring here when the focus is the solving by factoring. So that's a good place for you to fill in the blanks on your own in your notes afterwards if you're not following what I'm doing. So just an FYI about that. So on the left here, we're going to do the first one. We have t squared minus t minus 12 equals 0. So I need to factor the left part. And so I know that I'm going to have two sets of parentheses. And then I need to make sure that I make it equal to 0, because this is an equation. I know since it's multiplying to t squared that I need a t, oops, not a t squared, I need a t in the front of both of my parentheses. I'm multiplying to a negative 12, so I know I have to have a positive number and a negative number. So I'm going to just put in my signs. I know one has to be positive, one has to be negative. And then I know that the combination has to add to a negative 1, which means that the bigger number is negative. So this is a very common polynomial or quadratic to factor, and I know that my numbers are 4 and 3. And if I have a -4 and a +3, that gets me to a -1. And a -4 times 3 gets me -12. So this factors to t plus 3 times t minus 4 equal to 0. So I factored, and then the next step is the zero factor property. Oh, see, I said sometimes I say zero factor property, sometimes I say zero product property. I use them interchangeably. Sometimes I even say rule instead of property. But I'm talking about the same thing each time, so I don't get too confused over that. So that's where I set each set of parentheses equal to 0, essentially. So you have t plus 3 equal to 0 and t minus 4 equal to 0. So I'll go ahead and solve these. So the first one, t plus 3 equals 0, I'm going to subtract 3 from both sides to give me t equals -3. And then the second one, we add 4 to both sides. And this gives me t equals 4. Now in ALEKS, you might be wondering, well, how do I enter in my answers? Generally, they just want you to put it in with commas. So usually what ALEKS will do is they'll give you the little symbols, the little set symbol in there, and then your box is in between the set symbol. And so you just enter them with commas. But generally, you would have the little set symbols around them, but ALEKS will put that already on there. So you don't have to retype the curly braces. You just have to put in the numbers separated by commas. Let's take a look at the second one here. We've got 3p squared minus 7p plus 4 equals 0. So again, I need a factor. And so I'm going to just set up my factoring. And I'm multiplying to 3p squared. So 3 is prime, so there's only one way to do it, 3 times 1. So I know that one of these is 3p and the other one is regular p. In the back, I have to multiply to 4, so my choices are 1 times 4 or 2 times 2, and it's positive, but we're adding to a negative in the middle. So the only way to multiply to a positive and add to a negative is if they're both negative. So I've got 2 negatives there. And then I'm looking for my combination of the inside and the outside. Now, when I multiply and add, it gets me -7p. So this is going to be factoring as a 4 and a 1, where the 4 will be multiplied on the p, and the 3 gets multiplied with that 1, because that will give us a -4p and a -3p, and that adds to -7p. So I just always, after you put in your factor, you can kind of double check yourself by going through FOIL to make sure it multiplies back out to what you started with. So you can always double check what you've done when you factor. So now that I've factored, I'm going to use the zero product property, which I'm going to just abbreviate as ZPP, so I don't have to keep rewriting that. And you set each factor equal to 0. So 3p minus 4 equal to 0. And some teachers get really explicit and want you to put the word or in between them. I don't worry about that. I don't care if you put the word or there or not. Don't put the word and, because they're not necessarily both true. You can't have 2 values for p at the same time. So you would have one or the other. So you could write the word or there. I don't bother writing it. So I'm not going to take off points like on a quiz or whatever if you don't write it. But just as an FYI, because you know everybody's different. You could get a teacher in the future that really wants you to write that down, but it would be an or. So now I'm going to solve each of these. I have 3p minus 4 equals 0. So I'm going to start by adding 4 to both sides. So that's 3p equals 4. Then I'm dividing both sides by 3. And we get p equals 4/3. Second equation, p minus 1 equals 0. I add 1 to both sides. And we get p equals 1. So our two answers are 4/3 and 1. And the order that you put these in ALEKS doesn't matter. So they'll accept the 4/3 and then the 1, or the 1 comma the 4/3. It is smart enough to determine that. Be careful that you don't put p equals when you enter it in, because it will mark it wrong because it's expecting just the numbers. So just as an FYI, when you're doing your homework, that it's not expecting you to say give equations, it's expecting just the numbers. Okay, so on my next slide here, the difference between the previous slide and this next one is that these were all equal to 0, and then these are not equal to 0. So in order to solve by factoring, we have to get them equal to 0 first. So once again, I'm adding on another step here, another layer of complexity from what we did before. So we have to get one side equal to 0 first, and then we can solve. So I'm going to start with the one on the left. We've got 10x squared equals 15x. So the first step is to put it in standard form. Which means that we just want it to be equal to 0. So I'm going to just rewrite what we have here. We have 10x squared equals 15x. And I can choose, do I want my 0 on the left or do I want my 0 on the right? I like to put my 0 on the right. So we're going to subtract 15x from both sides. Now 10x squared minus 15x, these are not like terms, so we now have two terms on the left. We have 10x squared minus 15x equals 0. So we've moved that 15x, we've put it on the left, so now we have a minus 15x. Step 2 is to factor this. So this is two terms, and this means that we factor with the greatest common factor here. So the largest number that I can divide out of 10 and 15 is 5. And then I can also remove an x from both of those. So I'm going to have a 5x in front. And then 10 divided by 5 is 2. And I removed an x. So instead of x squared, I have x. Then negative 15 divided by 5 is negative 3, and I removed an x, so I don't have an x left there. So I have factored out the greatest common factor, and this gives us 5x times 2x minus 3 equal to 0. Next, we use the zero product property. So now we set each of those factors equal to 0. So I have 5x equal to 0 and 2x minus 3 equal to 0. And then I solve. So 5x equal to 0, I'm going to divide both sides by 5. And this gives me x equals 0, since 0 divided by 5 is 0. Then we solve 2x minus 3 equal to 0. So I'm going to add 3 to both sides. This gives me 2x equals 3. Then I divide both sides by 2, and we get x equal 3 halves. So we had to do an additional step here because we had to put it in standard form first. We had to get one side equal to 0 before we started factoring and then doing the zero product property. So a little bit extra work there. But then once you get to the factoring part, once it's factored, then you set up your two equations and you solve. Now on the right, we have a negative 11x equals 3x squared minus 4. So again, this is not equal to 0, so I need to get it equal to 0. And I try to do this by moving as few things as possible. So I'm going to make the left side 0 here because then I only need to add 11x to both sides versus moving 2 things to the left. So we're going to add 11x to both sides. So this will give me 0 equals 3x squared. And now I want to put these in order of the variables from the highest exponent to the lowest. So I'm going to put plus 11x next and then have minus 4. So this is going to be 3x squared plus 11x minus 4. Now it's in standard form because we have it equal to 0. So now I'm going to factor. So I'm going to set up my 2 sets of parentheses since we have a trinomial. I'm multiplying to 3x squared, and to do that we need a 3x times x. I need to multiply to a negative 4, which has to be done with positive or with opposite signs, either positive or and a negative there. But I don't know which one's positive or negative because it actually matters in this case because the x parts aren't the same. And then we need to add to 11. So multiplying to 4, we've got 1 times 4, 2 times 2. And if I put a 4 in the last place and then a 1 in the other one, if I multiply here, 3x times 4, that's a positive 12. So I want a positive 11. 1 times x is 1. So if I have a positive 12 and I subtract 1, that will get me my plus 11. So this factors to 3x minus 1 times x plus 4. So once you've factored it, then you're going to set each factor equal to 0. So I have 3x minus 1 equal to 0, x plus 4 equal to 0. And then you're going to solve each of these. So I'm going to add 1 to both sides for the 3x minus 1. So this gives me 3x equals 1. And then I divide both sides by 3. And I get x equals 1/3. Second one here, I've got x plus 4, so I'm going to subtract 4 from both sides. And this gives me x equals negative 4, and that's my second answer. So for the example on the right, we had to first get one side equal to 0, and it was easier to move the negative 11x to the other side because it was fewer things to move. Then I had to factor. Then once you factor, you set each factor equal to 0, and then you solve. So got about 10 minutes left, and I've got 2 more examples, so I'm going to just move on, and then if we have extra time, we can go over other questions. So my last 2 here are more complicated here. So on the left, I have p squared times p plus 7 squared equals 0. So this is not something that you're going to see too often. These are sort of special cases, these two examples here. Things that come up from time to time. So the one on the left, it's equal to 0, which is what we want, but we don't have linear factors. We have exponents on these things. So what you can do is rewrite this. So p squared means p times p. So you can rewrite that as p times p. And then p plus 7 squared means p plus 7 times p plus 7. So you can use the meaning of exponents, which is repeated multiplication, to just split these up so that now, and I can even put that in parentheses there, you have all of your things factored and multiplied out. So I split the p squared into p times p plus 7 squared to p plus 7 times p plus 7. So now we've got a series of multiplications equal to 0, so you can set each factor equal to 0 using the zero product property. So this p gives us p equals 0. This p gives us p equals 0. This gives us p plus 7 equal to 0. And then we also have p plus 7 equals 0. And you're going to see that we're going to get repeated solutions, because we already have two solutions that are 0. And then when I solve the p plus 7 equal to 0, and I basically solving both of these are identical equations, this gives me p equals -7. And so we get -7 twice. So if you have repeated solutions, we don't write them multiple times. So you would say your solutions are 0 and -7. So we have two solutions here, even though we really, when we solved it, we got 4, they're repeated, so you only have two actual different numbers here. So that's what I mean when I said at the very beginning that you have a maximum number of solutions. In this case, we have 4 things multiplied together, which would mean a maximum of 4 solutions. But because they're repeated, there's only 2. So that's just a kind of special case that you may come across when you start factoring these things, that you may have repeated answers and you only need to write it once. Now on the right, we have a times a plus 7, or a plus 3 squared equals 5. So this is not equal to 0, so we need to get one side equal to 0. So I'm going to subtract 5 from both sides. So this gives me a times a plus 3 squared, and then I just have this -5 because I can't really subtract 5 from this multiplied thing with like an exponent. This is not in the form we want. The form we want is ax squared plus bx plus c. We're not in that form. So we need to multiply out, and actually, because this has a, that's probably even more confusing, but we need to have a quadratic. We're not in standard form. So I need to multiply out the a plus 3. So if it helps, you can write that twice. So we've got a times a plus 3 times a plus 3, then we've got this -5. And we're going to just start multiplying this out. So first, when you have two sets of parentheses here multiplied, you're going to FOIL. So a times a will give us a squared. The a times 3 will give us 3a. Then I multiply 3 times a, which is another 3a. Then 3 times 3, which is 9. So I need to distribute this out first. So we have a times this a squared plus 3a plus 3a plus 9. Then this -5 equal to 0. I need to simplify what's in my parentheses. So my 3a's, I can add that and get 6a. Everything else is staying the same. Then I need to multiply out and FOIL again. I have to do the a times a squared, which gives you a cubed. And then we have a times 6a, so that's 6a squared. Then we have a times 9, which is 9a. And then that minus 5 doesn't get multiplied because that's not in parentheses. So now we've got this thing with 4 terms. We have a cubed plus 6a squared plus 9a minus 5. So this is not a quadratic because it's not x squared, it's not an a squared, it's actually got the highest exponent of 3. And when you have 4 terms, you would try to do grouping. So when you have 4 terms in your factoring, you would attempt to group and to factor by grouping. And if factoring by grouping does not work, then this cannot be factored. And at this point, we cannot find the solution. So I'm going to just tell you ahead of time that if you try to factor this by grouping, it's not going to factor. So this cannot be factored. So we can't solve by factoring. And that is where you need to try a different method. In this particular case, this method for something like this, where you have an a cubed and you have 4 terms, that's not going to be covered until week 6. So at this point, all you can say is that this cannot be solved by factoring. And we don't know, you have not learned it any yet how to factor this. And you won't learn how to try to solve this until week 6. But I wanted to show this to you so that you know, well, what happens if I get something that I can't be factored? If there's no other method that you know of to solve, then you just can't solve it at this point. But there is a way further down the road. But I wanted to kind of demonstrate this. And sometimes if you get a situation like this where you have something squared and you multiply it out, you do get something that you can't factor. So just because we had to do all this multiplication to put it in the right form, that doesn't necessarily mean that it automatically cannot be factored. It's just this particular one cannot be factored because it has an exponent of 3 and it's 4 terms, and grouping would not work. But there may be others that look sort of like this that will be factored. So you have to kind of look to see whether it could be factored or not.